So your database has accounting information. It's the database also has information, like I said, about quality of service, fair share, many limits. You can set limits by user. You've got a bunch of limits you can set by bank account in a hierarchical fashion. It's very flexible. It's very powerful. It's also fairly complex, to be perfectly honest, and I'm not going to get into that here, but that'll be covered in a later presentation. This gives you an example of hierarchical banks. The hierarchy can have any number of levels. It doesn't need to be balanced. So Division C over here could potentially have users directly hanging off of that, or it can have groups or however many levels you want. So some other commands you need to know about. Scancel is used to cancel jobs or job steps. That's pretty commonly used. sbcast is used to transfer files to the compute nodes that have been allocated to a job, and that uses the hierarchical communications that have already been described. srun_cr, the CR stands for checkpoint restart, and that's a wrapper to srun that's used to support the Berkeley Linux checkpoint restart software. strigger is an event trigger management tool, and I'll describe that a little bit more. Here's some examples of scancel. You can use it to send an arbitrary signal to all the processes associated with a particular job or job step. You've got various filtering options. So your examples here, canceling a particular job step, 45,001, and your step is 1. If you want to cancel a whole job, you can do scancel 4,502. You can do filtering, like I said. This example is a request to cancel all jobs belonging to user alloc that are in a pending state. sbcast, if you want to copy files to your local disk on your allocated nodes, say you want to put them on /temp, or you want to put them into a memory mounted file system, you can do that. It uses hierarchical communications. It may be faster than a shared file system, or it may not be. I mean, this is something we have available, and the example has you creating a resource allocation, broadcasting a file out to the compute nodes, and then running a program on those compute nodes. So sbcast doesn't accept a list of nodes. It just goes to all the nodes that have been allocated to the job based upon the environment variables that have been set up for it. strigger can be used to run an arbitrary script when certain events occur. So if a node goes down, or a daemon stops or restarts, or a job is close to its time limit, you can cause the script to be written. So for example, you might send an email message to a system administrator whenever any node goes down. The strigger command can be used to create, destroy, or list event triggers. It has an option for persistent triggers too, so that whenever any node goes down, it will execute the script, and you don't have to create a new trigger after it occurs. Next thing I'm going to go over is building and configuring Slurm. So first thing is, you're going to want to select a distribution to use and download a tarball. We keep the tarballs in the SchedMD website. We come out with a new major or minor release, I should say, about every 9 months, and that includes a substantial amount of new development typically, and that third digit changes when we make a new minor or micro release, typically about once a month. And if you want to get the very latest code base, not necessarily something that we've gone through regression tests or whatever, you can get that directly from GitHub. But in general, you probably, if you want to use this in a production machine, you want to use a version that we've officially released. Like I said, they come out about once a month, and that'll maximize your stability. So after you get the file, you can use the RPM build tool to build your RPMs and then install them here. So some of the RPMs are infrastructure dependent. So for example, if you're using opd for authentication, there's a slurm-auth/ there's a slurm-auth-authd RPM. The asterisk there is shorthand. The Slurm version will actually be embedded in there, so it'll be opd-2.3.1.rpm, for example. For a Blue Gene cluster, there's a Blue Gene RPM, and if you're running on a cluster with an Elan switch, you'd use the switch Elan. Those are just some examples. You'll have to look and see which RPMs make sense for you to use. If you're not using RPMs, there are Debian packages available, or you can just do a build in place. So you'll uncompress and unpack the tarball and create a build directory, go into it. I'll walk through this, and then you will execute configure. What configure does is it figures out exactly what your environment's like, where header files are, which compilers are installed, which libraries are installed, where they are, and so forth. The options that are most typically used would be -- prefix, which will tell you where to install the files, --sysconfdir, which is where the system configuration goes. Enable debug is something I use pretty regularly. That turns on some additional debugging while Slurm's running, so you can make sure everything's running properly. Then you would execute make to build the executable, and make install to actually install the files. So here's a walkthrough of that process. So cd, change directory, uncompress the file, and then unpackage the file. So tar is a packaging mechanism. It's what you would use to take a whole lot of individual files and stick them together into a single file so they're easier to manage. -x and -f say to extract the files from a particular file. ls lists what you've got, and this is a directory. Then I make a directory to do the build in, change directory to that, execute configure. Now this is in another directory. Do a make, which make is a tool that is going to go through all of the subdirectories and make all of the executables. So it's compiling all of these programs. The individual files are going to end with .c, so they're C programs. But a computer really doesn't run a C program. It runs a executable, which is just the ones and zeros. It's machine language. So make translates it into that. And then make install will actually install the files.